Good morning, students. Last class we discussed about the hydrocarbon, introduction of the hydrocarbons. The hydrocarbon is classified the two types, the aliphatic and aromatic. Aliphatic, it is again classified three types. Okay, alkane, alkene, alkyne. Okay. Then we discussed about the general formula also. Then last we are discussing IUPAC name of the branched alkanes. Okay. Last class we discussed the two examples. I will continue from there. Okay. First you see, this is the linear chain. Okay, 1, 2, 3, 4, 5. 5 carbonators. So 5 carbonators alkane chain means pentane. So you write pentane. Then you see this carbon atom containing the one attached group or branched group. Okay. So the nearest carbon is this one. So you put the number from left to right. 1, 2, 3, 4, 5. The second carbon atom containing the methyl group. So 2-methyl pentane. IUPAC. Then second compound you see 1, 2, 3, 4, 5. 5 means pentane. Pentane. You see this carbon atom and this carbon atom containing the methyl group or attached group. Okay. So from this, compare this example. Even if you put the number right side or left side also, no problem at all. Okay. So put in the number from the right to left. 1, 2, 3, 4, 5. Suppose you put in the number from the left means 1, 2, 3, 4, 5. Anyhow, the second carbon atom and fourth carbon atom containing the methyl group. So no problem at all. Okay. So the pentane, then the 2 and 4. 2 methyl group are present. So 2, 4. 2, 4 dimethyl pentane. Then you see the next example. This also, this left side also 2 carbon atom, the right side also 2 carbon atom. So no problem at all. If you put the number right or left, okay, don't bother. I put the number from the right to left. 1, 2, 3, 4, 5. Okay. So 5 carbon atom. So the name is pentane. The third carbon atom containing the 2 methyl groups are attached. So 3 dimethyl pentane. 3 dimethyl pentane. The next you see the carbon atom. Here also the attached group, the methyl and the ethyl. Okay. The nearest the carbon atom, this one. So you put the number from right to left. 1, 2, 3, 4, 5. So this name is pentane. Pentane. The second carbon atom containing the methyl group, third carbon atom containing the ethyl group. Now you see the two, here only the methyl group are present, here also methyl group present, here also 2 methyl group are present. But this pentane containing the 1 methyl and 1 ethyl group is present. Okay, now you see the alphabet order. Okay, when you compare the alphabet order, this is the ethyl group come before the methyl. Okay, E, M. So first you give the preference for E. Okay, when you see the alphabet order, so 3 ethyl, 2 methyl pentane. Okay, 3 ethyl, 2 methyl pentane. Then I will give one more example. Now this example, listen here. When you put the right to left, 1, 2, third carbon atom is the branch group. But here the second group containing the branch group. So you put the number from the left to right. The 6 mean hexane. The previous example eternal we have discussed about the 5 carbon atom. This carbon here is the 6 carbon is here. So 6 carbon means hexane. Hexane. The 4th carbon and second carbon containing the methyl group, but this is a 3rd group containing the propyl group. Okay, so you compare the methyl and the propyl. Okay, the first it is come the methyl. So 4, 2 dimethyl. Okay, 2, 4 dimethyl. 3 propyl. Propyl hexane. Okay, the next example you discuss yourself. Okay, if you have any doubt, we will clarify it. Okay. The next one is the preparation of alkanes. Okay, how to prepare the alkane. Preparation of alkane. The first one is the preparation of alkane from the catalytic reduction of unsaturated hydrocarbon. Okay, the first one is the preparation of listen, already we discussed that unsaturated means the double bond group and the triple bond group is known as the unsaturated hydrocarbons. Okay, already we discussed 3 types. Okay, this aliphatic and aromatic. Okay, aliphatic is classified again 3 types: alkane, alkene and alkane. Okay, here the unsaturated means alkene and alkane is known as the unsaturated hydrocarbon. Here the preparation of the alkane from the catalytic reduction of unsaturated hydrocarbon. So this the alkanes is prepared from the alkene or alkane group. Okay, alkene or alkane group. Then catalytic it means here the catalyst which is the used. Okay, what is catalyst? The catalyst does not react to the involved in the product, but it is the speed of the reaction or slow of the reaction. That is the catalytic reaction. Then this is the reduction reaction. The reduction reaction, you know, addition of oxygen or addition of hydrogen. Okay, sorry, removal of oxygen and the addition of hydrogen. Okay, here the alkane we are going to prepare the propane. So the propane is prepared from the propene. Okay, propane means 3 carbon atom. Okay, so CH3, CH double bond, CH3 plus H2. Then the catalyst is the platinum. Okay, here the mixture of the hydrogen and the propene. Okay, the mixture of the hydrogen and the propane is passed over the platinum catalyst. Okay, when it is passed over the platinum catalyst, this the propane will be converted to the propane. Okay, so CH3, CH2, double bond, CH3. This is the propane. This is propane. Then the second example, the presence of the nickel catalyst is heated at the 298 Kelvin. Okay, this is a preparation. Ethane prepared from the ethene. Okay, ethene is the two carbon atom. So CH2 double bond CH2 plus hydrogen. Here the presence of here the catalyst which is used the platinum. Okay, here the hydrogen gas and propane gas, it is the both mixture is passed over the platinum catalyst. Okay, here is used the ethene. Ethene and hydrogen gas, the presence of the nickel are heated at the 298 Kelvin. Okay, 298 Kelvin to produce the ethane. Okay, the next one is the also propylene. Propylene as triple bond CH 1 2 3 carbon atoms. So the propene here is the two single double bond. So ene group. Yes, propyne. Why? Any propyne group with the presence of the catalyst is platinum. CH3 will come. So 4 hydrogen atoms. Okay. The next one is the preparation of the alkane from the carboxylic acid. Okay. Next one, preparation of alkanes from carboxylic acid. Carboxylic acid. Okay, this is the first one. This is the previous example. This is the hydrogenation process. Okay, because the propane is addition of the hydrogen. Okay, addition of the hydrogen. So that is the hydrogenation process. This is the decarboxylation process. This one is the decarboxylation process. The preparation of alkane from the carboxylic acid. Okay, alkane from the carboxylic acid. This is a sodium salt. The sodium acetate. You have taken the sodium acetate. CH3COOH is the carboxylic acid. Okay, this name is the CH3COOH is the carboxylic acid. When the hydrogen is replaced by addition of the sodium, that is the sodium acetate. That is name is the sodium acetate. Okay, the sodium acetate with the presence of the calcium oxide and sodium hydroxide. And sodium hydroxide, when it is heated, the sodium acetate and sodium hydroxide, the presence of the calcium oxide to produce the methane plus from the sodium hydroxide and the hydrogen atom, this hydrogen atom will come in the methyl group to form the methane, CH4. The remaining things is the sodium, Na2, 2 sodium, Na2, remaining COO3. You get a sodium carbonate. Okay, you see this. Preparation of the alkanes from the carboxylic acid. The carboxylic acid formula, you know that CH3 COOH. Okay. When this hydrogen is replaced by the sodium, that is the sodium acetate. Okay, the sodium acetate with the presence of the sodium hydroxide and the calcium oxide. Okay, this is the compound. This the mixture is when this heated to form the methane group. Okay, then the remaining things, sodium carbonate will come out. Okay, this is the process is the decarboxylation process. The next one is the Gulf electrolytic method. Okay, this is also the sodium acetate. When the sodium acetate is undergoing the hydrolysis, okay, the hydrolysis is add the H2O. So prepare the ethane molecule and carbon dioxide, hydrogen and sodium hydroxide. Okay. The 2 sodium acetate and 2 water molecule to get CH3. CH3 single bond CH3. This comes the ethane. The next thing carbon dioxide. This is a electrolysis process. The electrolysis process, it means anode and cathode will come. Okay, this is the anode. This is the ethane and carbon dioxide is the deposited on the anode. Anode part. Then cathode. The remaining things is the sodium hydroxide and hydrogen. This is the dissociation of the water. H plus and OH minus. Okay, here is the 2 water molecules present here. So 2 H plus and 2 OH. Okay. This is anode part and the cathode part H2 plus this is a hydroxide come and join this sodium atom. Okay, so 2 NaOH. This is the cathode part. So this is the cathode, but this is the electrolysis process, the Gulf electrolytic method. The next one is the preparation of alkane using the alkyl halides. Alkyl halide means the alkyl group, it is combined with the halogen groups. You know that what is halogen group is the chlorine, bromine, iodine, fluorine. These are the halogen groups. When the chlorine or bromine or iodine, fluoride, it is combined with the alkyl group. That is the alkyl halide. Okay, now we are studying the preparation of the alkane using the alkyl halide. Okay, the first one is the by reduction with nascent hydrogen. Nascent means newly prepared the hydrogen. Okay, new hydrogen molecule is known as the nascent hydrogen. Okay, so alkyl halide, here taken the alkyl halide is the chloropropane. Okay, the propane formula you know that 3 carbon atoms CH3, CH2, CH3. This is the propane. When one hydrogen is replaced by addition of the chlorine, that is the chloropropane. So CH2Cl. So this name is the CH2Cl, chloropropane. Chloropropane is treated as the nascent hydrogen and also the reducing agent. The nascent hydrogen already I said to you, the nascent means new hydrogen. Okay. Then here is using the suitable reducing agent. Suitable reducing agent, zinc and HCl, then zinc acetic acid and zinc copper. These are the example of the reducing agent. But this example we have taken the zinc and HCl. we get the propane. CH3, CH2, CH3 plus HCl. Okay. The next thing is the Woods reaction. Woods reaction, we are preparing the ethane. Ethane from the ethyl bromide and sodium. The presence of the diether. Diether to get the ethane and sodium bromide. Sodium bromide. Okay. The next example is the preparation of alkane from Grignard reagent. Okay. First we are going to prepare the Grignard reagent. First we are going to prepare the Grignard reagent. Grignard reagent is methyl chloride plus magnesium. Mg to get CH3 MgCl. This is the Grignard reagent. The Grignard reagent, this is the Grignard reagent. Okay. Then the process of the water, the hydrolysis. When the Grignard reagent is hydrolysis with the water to produce the methane. Okay. Then physical and chemical properties we will discuss next class. Okay, students.